Season 2, Episode 4 of the SoothSight podcast, we tackle the toughest questions about responsible AI with the most brilliant person I have ever met, someone I have had the privilege of calling a friend and colleague for over 12 years, Dr. Murthy Kolluru. Dr. Murthy is an AI educator, entrepreneur, and globally recognized thought leader in the world of AI and data science. He holds a PhD in material science and engineering from Carnegie Mellon and began his career as a rocket scientist designing the material system for India's first intercontinental ballistic missile. His 25 plus years of work in data science has spanned AI research, higher education, product development, and consulting for Fortune 1000 and Global 2000 companies. He has also led multiple successful exits. Dr. Murthy has a track record of building some of the most rigorous and respected bachelor's, master's, and PhD programs in data science anywhere in the world. He has taught over 10,000 corporates and many more students. He has also designed curricula and trained professors at top academic institutions across 4 continents. As Soothsayer, he leads our academic and corporate education efforts. Few people are as uniquely qualified to dissect not just what responsible AI is, but how it must be engineered at scale. This conversation is not about buzzwords. It's about the hard questions. It's about the mathematical, the philosophical, and operational realities of making AI trustworthy in high-stakes environments. As mentioned in episode 3, I have ulcers on my vocal cords for months now. My voice only started coming back in the last few days, so sorry in advance if my voice fades or strains, but trust me, this is going to be the most insightful conversation you have ever heard about responsible AI. Dr. M, thank you for joining us.
Oh, it's my pleasure and privilege to Chris to call you a colleague and friend, and I'm super excited to share, some of the thoughts and some of the insights that we have been building at Soothsayer for the past decade, particularly so in the past 3 to 4 years in this Gen AI wave. Please go ahead. Thanks for the opportunity. I really appreciate it.
I've been trying to get you for a year and a half. You're a busy man.
Well, yeah, yes, but thank you. Better late than never.
Exactly. Sure. So let's start interesting. So AI is probabilistic by nature, whether it's deep learning, Bayesian inference, or statistical decision making. Every system we use today operates on probabilities, not certainties. Yet human decision making, especially in regulated industries like law, medicine, insurance, these all demand determinism, and they're built in a way that, or more or less, built on the why being clear and explainable. So the question is, what does responsible really mean when AI is built on statistical uncertainty, but the real world demands absolute accountability? And then how do we reconcile these fundamentally opposing paradigms when designing responsible AI systems?
That's a great question to start with, Chris. See, one part of responsible AI is building accurate systems. There are a few other things. For example, environmental impact of AI systems has nothing to do with its accuracy. But we'll come to that later. Let's only look at accuracy. See, when you're talking about AI's responsibility, you have to understand that AI makes 3 to 4 types of mistakes. And make no mistake, even humans make them. But they become more prominent in the context of AI because AI can scale up and can be installed and deployed in multiple places and reach out to multiple consumers simultaneously. So one error that you pointed out is this fundamental statistical error. Any event that I am trying to predict, the moment I am predicting has a small noise associated with it. There is a probability that it happens only, or there is a probability that it may not even happen. So nobody is questioning that inaccuracy when one is talking about AI responsibility. There are 3 other errors that are cropping up nowadays. Actually, 2 of them were popular or were common even in the past. The last one is coming up now. Let me walk you through each one of them. The first one is bias. Okay. There is some inherent bias that human society has. And when data is generated based on the societal interactions, and when you feed that to an AI system develops the same bias. Something like around 10 years back, Google came up with a wonderful way to represent words as vectors. And they even were able to show that it follows some simple arithmetic of vector operations. So they took the vector of king, subtracted the vector of man, added the vector of woman, and they got the vector of queen. So king minus man plus woman is queen. It's very impressive that they built a system like that. But when later they tried the same thing on doctor minus man plus woman, it said nurse. A programmer minus man plus woman, it said housewife. Something like that. Blatantly sexist predictions. Now, they only trained this model on available books, available Wikipedia kind of web pages. But it turns out that in our day-to-day writing, probably we use the pronoun he a lot more for doctor and she for nurse. And so it said, okay, man, woman, doctor, nurse, it just got confused. So the second type of error that AI makes is this bias. And as we are training AI systems with larger data sets, it's becoming that much more difficult to identify these biases upfront. You have to make a mistake and then say, oh my God. And removing it also is very difficult. Google tried that to remove it. But one of the Gemini systems that they uploaded where they tried to remove all biases became controversially biased in the other side. You know, when someone asked, generate a picture of founding fathers of America, it refused to show any white male. Interesting. I mean, it's factually completely incorrect. So the bias is so inherently intertwined in the writings and in the culture. Removing it can make it factually useless. Keeping it is potentially harmful. So one has to play it very, very carefully and requires a lot of research. The second one is corner case scenarios. So typically, machine learning models are trained on certain data. Now, if I ask it to make a prediction on a data point that I never trained it with, okay, it is likely to make mistakes. Or I mean, I never trained it with, not in that distribution, completely outside. Let me take a non-technical example. So let's say I train a model to detect when I upload a photo of a sports person or a hero or a heroine. Let's say the model is trained to show similar looking people from my database. Let's say I'm running a dating site. So I want to actually, have a favorite person and I upload that and I'll see people who look like them. So the model is well trained on human data. Suddenly, let's say if I upload a chimpanzee or a gorilla or a crocodile, now the system may pull out a few photos because it probably looked at some features and it looked at on those features who is the closest person in the system. Now this is a corner case. I didn't train the system on non-human data, but I'm asking questions on non-human data. Again, a human will never make such a mistake. And AI system has to be guarded well enough to not make that mistake. It should say, look, I'm not trained on this data, so throw it away. I will not predict. But AI systems don't know when to say no. Particularly the new age generative models are a lot more naive in that sense that they just don't say no. Okay, previously we used to throw a 404 error whenever we didn't know the answer. ChatGPT doesn't know to throw a 404 error, and that's a big problem. And the last one is hallucination. See, the problem is our scientists are trying to make AI systems as creative as they want them, as they can. So they are making them highly probabilistic. So I ask the same question, it gives different answer in different time periods. I mean, I ask it today, it gives one answer, tomorrow it gives the other answer. So I'm making it extremely creative. Now, if you think about it, can you be creative without imagination? No. Imagination is foundation stone of creativity. Now, that's the problem. the when the computers or models imagination doesn't align with my imagination, I say, hey, it is hallucinating. Hallucination is a highly imaginary answer, so imaginary that it's probably wrong, or it's something that I never expected. So it's not actually a design problem. Well, these systems, Gen AI systems, are designed to be creative, and when they are imagining and being creative, I am complaining they are hallucinating. So the problem there is I am building a AI where I should be probably building using a much less imaginative AI. So humans are a lot less careful nowadays about all these three: the biases in the data, the the corner cases, what I trained on and what AI is not trained to answer on, and am I using too powerful a system where probably I should use a much simpler system. Responsible AI is about guiding people to do these things correctly as far as accuracy is concerned. As I said, there are other parts, but inaccuracy. It's not about reducing the first part, which is the statistical error, which we have to live with in any prediction. Okay, so I think that turned out to be longer than you wanted, but that's a very detailed answer to that
Podcast is
statistical
over,
nature.
ladies and gentlemen. So thank you, Dr. Murthy. I'm just kidding. No, that was great. Thank you. So let's take like in aerospace and bridges, semiconductor design, engineers aren't eliminating failure, right? They're designing within acceptable failure rates. So then should AI be approached the same way where it's, I guess, where responsibility is not about eliminating bias or risk, but defining acceptable error margins?
Absolutely. In fact, when I train corporates, what I tell them is the simplest way to understand responsibility is what should you put on the cover page of a AI product you're selling or you're building or you're buying. See, when you look at a drug, paracetamol, it doesn't say I eliminate side effects. It at least says these are the side effects. These are the allergens. You should not take any more than 3 pills per day. Whatever, whatever guidelines it gives. At least we should start with that. When we are buying or selling an AI system today, our the amount of information the consumer gets, they don't get what data I tested it on, what kind of mistakes it made during my training phase. All they say is, look, XYZ can make mistakes, be careful. Now that's not enough. It's almost like saying, look, this drug has side effects, figure it out. You can't get away with that in a pharmaceutical world, simply because the regulators know what questions to ask. In AI, they're still figuring out. So the maker should be that much more responsible to tell the world that, look, these are the tests I did. This is where it failed. This is where it worked well. So use it under these conditions. That's all. That's a very good start, actually. And from there, version by version, we'll improve, minimize the side effects, minimize the allergens, minimize whatever. So but I completely agree with you. That should be your approach when you are building an AI system. But by the way, Google is one of the very few organizations that actually started this activity very rigorously. Okay, so they said they are coming up with model cards where they actually tell where their system breaks down, what kind of data they used it to test on, etc. But there is so much of competition nowadays. The large companies just don't have the time to do all these tests, have the willingness to share where all it failed upfront, candidly. That's a different, it's an economic competition more than anything else.
Then if we want AI to be responsible, should it always err on the side of conservatism, let's say high precision, low recall, or should AI responsibility be contextual where we're maximizing exploration in some domains? So you mentioned pharmaceuticals, so drug discovery, but minimizing risk in others. So let's say criminal sentencing.
Okay, that's again a very philosophical question. The way I actually would like to approach that is, any AI, when it is making a prediction, I think it should show its vulnerability. That the moment it shows it, human starts relying on it a little less. For example, let's say when I was studying engineering, which was long back, and I don't want to think about how long back it is, but at that in those days, not knowing 17th table was blasphemous. We had to know it, right? But if I ask a Gen Z kid now, what is 17/8? Obviously, he or she will not be able to answer because they outsourced tables to a calculator, which is perfectly fine. They're not doing any less math. They're actually solving much tougher problems than what we were doing. But just tables are outsourced, which is okay because tables are definitive. Machines, on the other hand, I cannot outsource decision making to a machine, though human has this tendency to outsource it. The moment I see a system, I tend to outsource my decision to it. And MIT did some wonderful research on this some time back. They took a ML model, I think in medicine diagnostics, and they added one last line where if the machine prediction is the guy has that illness, the output is he doesn't have that illness. If the machine predicted he doesn't have illness, the output is he has illness. So just they flipped the output and found that 29% of the doctors, experts, not fresh doctors, experts, were misled by the AI prediction. They would have given the right prediction if they didn't have the AI system next to them. So humans tend to outsource their decision making to machines if machine acts like it is not confused. Okay. And that is what most of today's language models are doing. You ask a question, they give an answer. They don't tell, you know what, on this answer, I am only 72% confident. Probably I made these mistakes. Think about it. Even a simple machine learning model, it says this customer will churn. If only it said, look, I think I'm only 78% confident that this customer will churn. In the past, customers very similar to these customers, these are the 4 examples where they did not churn. Whereas these 8 examples where they churn, based on this, I'm predicting like this. Then that becomes a decision assisting tool. So I am not as concerned about its conservatism or liberalism as long as it appropriately exposes its vulnerabilities. Look, I'm not confident in this answer. So it is the responsibility of the designer to figure out how to make that in big font upfront saying, look, I'm only this confident on this prediction. So use it with a pinch of salt. Okay. So like a regular expert does, a true expert doesn't feel bad to tell that, look, I'm not really confident about this answer. Let's check it out. Let's work it out. I think we should build it like that.
And many companies treat responsible AI as more of a compliance checkbox or a PR strategy. So from an engineering perspective, what must be done differently in model design, validation, and deployment to make responsible AI real rather than performative?
Absolutely. This is a very, very important problem that I face whenever I talk to a company. And for a reason, see, nowadays, thanks to LLMs, coding became very easy. And now they have these agentic AI systems where the one LLM asks the other LLM to do something and they together solve the task. It turns out that building these systems is very easy. There's no, what used to take months now probably takes a couple of weeks. So going to a business and telling them, look, that is less responsible because it's hallucinating, it is expensive, etc., is not the right way to solve, because their biggest concern is, look, if I don't go into the market, my competitor will go. So nowadays, what I normally advise corporates is, yes, of course, get your PR mileage and everything. That's a great, tool to get. I'm being more ethical, more responsible is always a good thing. But when you're building a product, start with a complete Gen AI prototype. Don't worry. I mean, build it. 3 weeks, get it into the market, but be responsible. Tell that, look, this is a prototype. I did only this. I did only this. So under these conditions, it worked well. You don't even have to define where it didn't work well, but at least share with the world the kind of test that you did, saying, here it worked well. Then have your architecture team sit and figure out what elements here are environmentally less sustainable. What should I replace? See, building a true machine learning solution will take 9 months. Building a prototype Gen AI system will take 1 month. Now, the final ML system, which may have some LLM, which may have some machine learning model, symbolic AI, will be a lot more optimal, a lot more economical, environmentally sustainable, secure, all that is there. So build the prototype and let your designers now come back and tell you if we replace these 7 elements in this system with these traditional guys, our cost will come down by this much, performance will go up by this much, error rate will come down by this much, whatever they can give. And then identify the minimum viable steps. Step 1, I will replace element 2 because that is the quickest. So go all the 9 months, replace one element at a time while you are functioning. So start with a less robust, quick to generate, but more expensive solution. In a few months, step by step, evolve into your final product. So while you then get the mileage of responsibility and ethics and trustworthy AI, you also are in the market upfront with a complete idea that, hey, you know what, this is how I evolve into the more responsible solution while not losing the market share. And the teams, engineers have to be trained in this new way of building. This was not the case in the past. In the past, machine learning took what it took, that 6 months, 9 months. So everyone is now excited about building that 15-day solution. So you have to spend that extra time to get your teams to think about the issues with the prototype and improve on it step by step. And many times when I check real world systems that people build, I do feel, hey, you know what? This is a prototype. You really didn't test the performance metrics because you didn't even know what performance metrics to put in. You didn't test how much of infrastructure you are wasting. You can probably replace this LLM with a simple forecasting model, and that GPU can be replaced by a CPU. And companies have a direct cost benefit there. It's not about next generation carbon emission. It is today I'm spending $1,000 per day, I bring it down to $10 per day. That's money right there that the companies can see. So one of the things that we are working on is coming up with a alternative metric system for performance metrics called green metrics. And green accuracy and accuracy. Just normalize it with some of these business factors, not just carbon, but also economic. So a highly expensive 90% and 1,000 the cost 89%. Once I normalize with the greenness, the 89% system may become more relevant for the company. Just that thinking process has to be built in. Okay. But yeah, that's the engineering that we need to bring in. Yeah.
To go back to bias, it's often framed as an ethical failure rather than an inherent mathematical property of AI. Even when using like a simple rule-based model, we're still designing the rules, right? And bias can still creep in. So is a bias-free AI model even possible?
You're absolutely right. Bias comes from data. And data is generated by humans, right? So we all have biases. So is a bias-free model possible? Mathematically, can I take all the biases and remove? I think theoretically I can do that. Okay, I'm not talking about here that mathematician's language of will I get to 100 or 99.9999. That's okay, I can get there. But my bigger worry is what I told in that example of Gemini is removing bias, making the system useless. So that's my bigger concern. What they did, I removed the bias of gender, made it like really completely non-racist, non-sexist. And then when I asked founding fathers of US, you imagine, it just didn't imagine the right answer. So the simple number prediction is one thing. I think biases can be completely eliminated. So demand forecasting, I don't think there'll be any bias in the data also. Resume filtering, yes, if there is a sexism there, I can probably remove it with some work. But when I'm generating data, um, paint a picture of whatever, this is based on my past experiences, my worldly interactions, etc., which are all bias driven anyway. Now if I completely remove the bias from that, will it even be able to paint something that I am wanting, is my bigger question. So when I am trying to reproduce the real world, um, with AI, which is what this generative AI is about. Like, I want a machine to almost talk like a human, draw almost like a human, or like a human. Why almost? Removing bias will make it less human like. Right? Because we all come with biases. So mathematical feasibility, yes, there are methods and it's an active area of research, so we can get rid of as much of it as, last bit is what will be left probably. In some cases they can be completely avoided, but they will become less relevant for use, day-to-day use. So I would say, um, in problems where we want AI to act like a human, I think they have a word for that, anthropic AI systems or something like that. So where they act like a human, removing bias altogether is not a good idea. Where they just want a forecasting, classification, recommendation kind of an engine, I think you can remove the biases completely without any worry. Mathematically, are we there? Simpler problems, I think there are very powerful techniques to remove it. More complex data, it's an active area of research, but tremendous strides have been made. So we are in that top 3-4% bias left kind of a scenario.
Explainability is often treated as a prerequisite for responsible AI, yet the most powerful models, let's say, transformers and so on, are fundamentally uninterpretable at human scale. So, one, are we chasing an impossible ideal here? And two, should we abandon explainability as a core objective and instead focus on quantifiable metrics like reliability, robustness, and bounded uncertainty?
Wonderful. So, first thing, explainability, I want to spend some time on defining this because it's so important. When you look at a problem, a AI model, most people wrongly assume that the explainability for that model is fixed. It's not. First thing that I normally ask myself when I'm designing, thinking about explainability is, who are the stakeholders for this? For example, imagine a very simple application like probability of default. So banks run this model to decide whether they should give a credit card or a loan to a end user. Now, what is explainability for that? What kind of explainability should I design? I get to the right conclusion if and only if I first define who are the stakeholders. There is a regulator, there is a business sponsor, and there is an end user, and there may be other stakeholders, but let's take these three. For the end user, the explainability that she or he needs is, if they are rejected, they should know what should they do to get accepted in a quarter. They should see something like, hey, you know what, you should pay your credit card bills in time, or you should maintain this much of balance in this account, or pay off this loan, whatever. That is the explainability they need. For the sponsorer, he needs to probably know which subgroups are paying the loan with the maximum percentage of minimum default percentage, so that I can now focus my marketing on those subgroups. For the regulator, he wants to know, hey, you know what, is my model discriminating between one race to the other, one gender to the other, one subgroup to the other subgroup? You see, explainability is completely different for all three stakeholders. First, I need to ask myself, when I'm designing explainability, who are the stakeholders and do they even need explainability? For example, a face recognition system, I'm replacing a human guard with a machine. Human guard also doesn't explain how she is able to recognize my face, right? She never says, I think it is Murthy because your eyebrows are turned. Like, no, they say this guy is this. And we are okay with that. So why should I want any additional explainability from a machine? I don't need. So for each stakeholder, now I should define what explainability is needed. And then you have this made this very powerful point that, look, these larger models are extremely difficult to explain. Now, as an architect and an engineer and a business functional expert, I have to ask myself, hey, you know what? Is explainability so crucial that I have to build a simpler model? Then, if it is that important for the human, yes, build a simpler model and explain why you are building that simpler model. Hey, it is not really needed. It has to generate the text. I really don't have to explain why I generated that. As long as it is accurate, I'm good. I can use a transformer. So explainability is as technical as it is functional. So it requires a thorough brainstorming and understanding for that application where I need tremendous explainability, where I don't need as much, or where I don't need anything at all, and putting the right kind of ML AI systems that have the right degree of explainability to make it useful. At some level, all this is about making the system useful. So will I take explainability? Yes, if it makes the system more useful, I'll keep it. Will I avoid explainability completely? If it doesn't hurt the system utility, I'll keep it. So it is true that thinking like this makes one design more responsible systems. But implementing explainability by itself doesn't make the system responsible. But thinking about who are all the stakeholders, how will they use it correctly, what should my system say, makes me design my architecture with simple, complex, appropriately, and all that stuff. Yeah.
AI governance frameworks assume that human oversight mitigates AI risk, yet human decision making is often just as biased, inconsistent, and flawed, if not more so than AI. So, are we designing governance models based on an outdated assumption of human superiority? I suppose the other half of that question is, should AI be treated as a decision making co pilot rather than a subordinate tool? And what would an optimal AI human governance model actually look like?
Okay. There are multiple questions here. So let me try to answer one at a time. And then if I forget, please bring me back to the loop. The first one, AI human superiority. So you're absolutely right. There's no need for us to assume human superiority. And nowadays, people are using AI to generate data. Which was not feasible some time back. But there are areas like, let's say, legal frameworks. These are actually written by humans because they understand, and we all have decided to live in a certain way. So United States decided to be democratic, decided to conduct elections in certain way, decided to do things. There's no right or wrong answer. I mean, a different country follows a different system. So in areas where I want AI to systems to function where the human society decided how it should be, I think human superiority is a fairly acceptable criteria because we as at some level are deciding. On the other hand, there are areas where humans don't have any say whatsoever. I mean, at least explicitly, implicitly, they may have stock market fluctuations, weather, whatever, these weather predictions, etc. One can argue whatever we do now may affect something in future, but that's very implicit. Explicitly, we are not controlling them. There, governance, human feedback or human engagement should only be to, again, improve the performance, improve the utility of the system, rather than forcing a human to be there for the sake of keeping a human there. Right. See, in general, coming to your second part of the thing, I am a big fan of building systems as doubles partners for humans. I'm a big fan of that. There are some shots that they play on their own, some shots I play on my own, but really to win the match we have to play it together. So That I think is an ideal design, and I believe some of the most powerful AI can be built if I build it as a reasoning system where a human and a machine actually brainstorm to do things together. Okay, so that is an ideal design. But given that, again, application based, in some, I may have to tell the AI system, look, this is the rule book that you must follow. This is the legal constitution that we agreed to do, just do it. In some, AI can say, look, I looked at 1 million data points and tomorrow it's going to rain. You shut up and just follow what I say, because they are very good at it. So let's listen to that. There are some areas where I think a brainstorming will be much better, where as a doctor, I say, look, I think this guy has this particular issue and I want to treat this way. Then the system will say, look, of the 180 million records I have, majority of them treated it slightly differently. Don't you think that should be the way? Then the doctor can say, look, in my experience, while that is a good thing, these variations that I brought in really changed the patient feel good factor and the friendliness that the caretaker was giving, whatever, it made the patient happier. So then they brainstorm. So governance as a human dominated thing, as you very rightly pointed out, is more of a older era thought, generated out of fear of AI replacing human. But if we educate people that AI is going to be a doubles partner in some cases, in many cases it is not even going to be that, and in some cases it will replace us. Just they are better at it. It doesn't mean we don't have work. It just means that we we are using a tool to do what it does best. So if we take that view, the governance becomes a lot more balanced. Okay. Yeah.
Frameworks by their nature are designed to mitigate risk through constraint. Yet AI's most transformative breakthroughs emerge from an environment of unbounded experimentation, meaning every bureaucratic checkpoint inherently slows the iterative cycles that drive progress. When regulation is static while AI is evolutionary, the result is this asymmetric drag on innovation where nations and organizations bound by restrictive policies fall behind less regulated competitors, not because their technology is inferior, right, but because their capacity to explore its full potential is artificially suppressed. So my question here is, with AI breakthroughs like China's DeepSeek disrupting markets, Grok 3 claiming to crush that, and everyone in math, science, and coding benchmarks in the US is whatever, last I saw, I think $500 billion, Stargate project redefining infrastructure at scale. Are existing regulatory frameworks nimble enough to adapt, or are they becoming bottlenecks that stifle innovation and hinder progress?
There's a lot of philosophical angle to this. So there are some parts that I may not be able to answer correctly also, but I'll give you what my thoughts are. Absolutely. In fact, many people believe that some of the restrictions that European Union set on itself to be ultra conservative or ultra, in fact, they were calling it safe AI, trust AI. These are sort of very wrong terminology to use. Saying I am practicing safe AI, it almost sounds like someone else is practicing unsafe AI. There's nothing safe or unsafe in AI. It is how I use AI. Car is a car. I drink and drive, it becomes unsafe. I drive carefully, it becomes safe. So I don't call it safe car, unsafe car. I call car safe driving, non-safe driving. People, Europe didn't do that. They said safe AI only I'll practice. So people got confused, scientists got confused, and they were left behind. So a mindless bureaucracy is going to make innovation hamper, impede the growth of innovation, like in other technologies. I think we should give some freedom to the academicians to just pursue, ask the questions, solve the problems. I think that's definitely not a bad thing at all. And in fact, interestingly, this whole DeepSeek thing, when you look at what DeepSeek did. They didn't do anything that was not published in the past, and 99% of that was published in US journals by probably US scientists, though I didn't do the statistics of it. The 15 things that they did to make DeepSeek more efficient, like distillation, like quantization, like LoRa, everything is a known technique. So I think the difference, the DeepSeek, I don't see it as a competition between USA and China. I see DeepSeek as a competition between a well-funded, closed scientific community to a constrained open source community. And typically the latter wins. The constrained open source community, because they don't have too much money, they have to find hacks, and they have to build differently to get to the same result. And if you look at OpenAI, Gemini, Amazon, they were just having a great time where the parent company said, take billions of dollars, do whatever you want. And they were a group of like 300 scientists, 200 scientists. Whereas DeepSeek, they said, I will give you 100 the money and do something, achieve this. I don't know what were the constraints, incentives that were there. And so they really had to go back to the literature, identify the top 50 things that were invented to reduce the size of a neural network, and figured out what cookbook, which 10 in a sequence gives the best result. And they did a remarkable job, the phenomenal innovation. But that innovation is because of open source. So a country like US, which has this wonderful university system, or any country for that matter, but which has these wonderful systems, have to figure out, particularly in AI, how to foster that open source culture, which is already there. I mean, majority of computing in the last 10 years is all about open source, right? Open source culture, and put very little bureaucratic hurdles there. But at the same time, I think, we can't completely ignore other impacts. AI does consume a lot of electricity and water. So someone has to ask that question. But the most natural way is, if you leave it to open community, there are enough people who will ask those questions, and they become important. And then government can put some guidelines saying, like what they did for cars. If you emit more than this much of carbon dioxide, you have to reduce it. For the plants and everything, they have those restrictions. They can come up with that. So open source culture, I think, is essential for AI progress, and it should be actively encouraged. And what was the third question? I forgot, or maybe I answered.
No, I think you covered it.
Okay.
Improperly built AI systems are brittle. They often fail under real world conditions due to data drift, shifting priors, unseen variables, whatever it may be. But in your time as a material scientist, you engineered robustness by understanding degradation, stress limits, and structural adaptation at a fundamental level. What principles from material science should be applied to AI to make it more resilient? And are we fundamentally designing AI with the wrong assumptions about stability and long-term performance?
Okay. This is a very interesting and important question. And my engineering background actually helped me think about this problem more deeply. In engineering, we don't do anything fundamentally different, actually. However, we had this great advantage, and today also we have this great advantage, that the world realizes that to build anything physical, it takes time. So when my first job, when people asked us to build a component for a ballistic missile, we spent at least 6 months just thinking about design, parameters, architecting, what materials I should choose, just brainstorming, asking the right questions and designing. That's because when it comes to physical things, people understand it takes time. People lose that understanding when it comes to digital world. Recently, I was talking to a CIO of one of the largest integrated steel plants. And the first ask he had is, look, we are in a real hurry to establish ourselves. So I want the solutions to be up and running Prototype is okay, but in the first 2 months, 8 weeks. Nowadays, whenever a client talks about AI, they talk about weeks, 8 weeks, 4 weeks, 2 weeks. If you have to build even a prototype in 8 weeks, you don't have any time to design. You don't have any time to think. You have to start coding. The failure of AI is not because of um, problems in coding. It fails because we don't think enough before we start coding. So what I encourage companies leadership is create at least a simple framework. In fact, we're creating framework for that, and our framework is called Darwin. D for data, A for architecture, R for responsibility, W for workflow alignment, I for infrastructure, N for nexus with people and processes. So Darwin essentially asks the designers a few questions, and it makes them think and answer. If you spend those 2 to 3 weeks brainstorming, okay, this is what and how I should build it. It may take 4 weeks if it's more, or 6 weeks if it's more complicated. That's okay. We all know that spending time in thinking about the design is not a waste of time. It is essential to build a good system. With digital things, people lost that completely. I'm sure you approach many clients. So many times they say, I want the solution in the first 2 weeks. And that's why I say, okay, build something with the Gen AI, but call it a prototype at least. Be honest and tell this is where it doesn't work. This is how I should improve. So fundamental things that we should learn from engineers is spend some time in design and know that the very first thing that you build is going to be a prototype. So build it in small scale and know that it will not work. So don't drop it there. Figure out how to improve it and take it to the next level. Finally productize. What companies are doing, they're not spending this design time. When they build the prototype, they assume that is the final product and are upset that it's not working, and 80% of the projects are dropped at the prototype stage. Just be more patient. AI, like anything else, takes time before it starts delivering the value. If you just have to do it right. So that's how I encourage people to learn from engineers. And I again think from pharmacy, I work a lot with healthcare companies. One beautiful lesson I learned from them is fail fast. In pharma, to invent a drug, it takes 5 billion. And in that, successful experiments are only 500 million. 4.5 billion is on wasted experiments. So the success in pharma is not designed by or defined by how many drugs you invented. It is defined by how quickly you failed in the wrong experiments, because even a 1% reduction in failure brings down 4.5 billion by 450 million. Whereas even a 10% improvement in success doesn't get it there. Sorry, I may have gotten wrong. 45 million. I said 450 million, but yeah.
With the rise of generative AI, we are seeing incredible creative potential. You were talking about this earlier, but also significant security and ethical risks such as prompt injection attacks. How can organizations ensure their Gen AI models are secure, responsibly deployed, and safeguarded against threats like data leakage and malicious misuse?
Yeah. This is an engineering solution that they have to come up with. My answer to that is make the model smaller. Shrink it, baby. I mean, we have, last 10 years is all about building big. I think next 2 to 3 years will all be about building small. We built these monsters, right? They can do anything. They can advise you on how to make a chicken recipe. They can advise you on how to come out of grief, and they can write Python coding. Why do I need a single system to do that? When I build a single system to do that many things, obviously it makes mistakes. People can misguide it and they can do all of that, right? Instead, I think next 2 to 3 years, there'll be a lot of emphasis on building systems that can only write Python code. You ask it to write Java code, it'll shamelessly throw in a 404 error. It will say, I don't know how to do it, right? So once you have these smaller specialized models, okay, we call them farm LMs, focused reasoning milli models. Farm LMs, once we have these specialized models, it's about orchestrating them to solve a problem. And no single model actually can answer or can go wild. It's very specialized to do a single task. If I ask it to do anything else, it throws an error. So organizations have to realize that the large models have their purpose, but large models do not solve all problems. For some, I need a lot of specialization. Okay, and build it. In fact, when I said you start with a prototype and move to a final solution, this is one of the things we normally encourage people to think about. I started with, okay, Gemini and a OpenAI and a Claude and a Llama, billions of connections and all that. Good, my prototype is working. Then I'll ask myself, hey, you know what, this will lead to data leakage, this will lead to prompt injections, prison breaking, all kinds of things, right? So can I replace it with more specialized model that is dumber, a lot dumber than this, in the sense that it doesn't know about everything in the world, but it knows about that one reading financial documents really well. Okay, it only does that, and I can build a machine learning model on top of that to say anything that is non-financial, it will throw an error, or I can build it internally also to say that. And if I build it like that, then automatically the systems will become smarter and in that task, and much more understandable, and they don't do anything that you haven't expected. So I think going small is the solution to the problem of these leaks and lack of robustness in the systems.
Of course, AI has accelerated innovation, but it has also placed powerful tools in the hands of bad actors, fueling misinformation, fraud, and uncontrolled proliferation. So, should AI remain fully transparent to uphold open innovation? And you started touching on this earlier, but to finalize this point, or is it time to impose access restrictions, knowing that doing so could concentrate power in the hands of a few and create even deeper ethical dilemmas?
I don't think we should have access restrictions. In fact, anything I said, you should promote open culture. See, we had nuclear power for 80 years, and we had some pretty crazy leaders during that time. Okay, but the fear of mutual destruction held it. So I am less worried about a few bad actors using it incorrectly, and it's a robber and a cop game, right? Some bad actions are done, and then we will fight it back, and all that happens. So I think that's an economy, and that's a process by itself. What I am more worried about, on the other hand, is, and why I spend a lot of time talking about responsibility, is when something is really easy, made easy, which is what is happening. Coding is becoming easier. Building AI systems is becoming 10 times easier, 100 times easier than it was even 5 years back. And people actually brag about it. This is a no-code AI system. You can more or less talk to it and you will build an AI system. When you make something extremely easy, my concern is the regular developers actually end up making too many mistakes. So I am not worried about a few bad guys, that 5% bad guys who are doing something bad with AI. I am worried about 95% of good guys who suddenly can do so many things with AI without realizing, add a small mistake here, small problem there, making things that much worse. So I think open culture should be promoted, but simultaneously, this entire thinking, designing responsibly, that training has to be given from ground up. The more easier you make development, the more of this responsible AI framework that you have to build around your tool or your product. So the product makers have to really understand that making things easy is almost equal to inviting people to make more mistakes, and design their product accordingly with all the responsible layer. That 5% bad elements, we have been dealing with them, right? We can't stop them. They will invent, even if you block it, they'll figure out a way to steal the technology, and they will then continue to do it. So I'm not really that worried about that.
Earlier we talked about DeepSeek and Stargate, and then if we throw in things like Europe's push for AI sovereignty and the broader rise of AI nationalism, and I'm wondering if we're witnessing a shift here where geopolitical ambitions overshadow ethical considerations in AI development. So, uh, I guess, should nations focus on building proprietary models to stay competitive, or does this trend risk compromising the principles of responsible AI?
Okay, so this is my take, which means you have to take with a pinch of salt. Most of the things I talked about until now uh, are somewhat factual. There are multiple people who supported what I did, but now what I'm going to say is my personal opinion. Okay, am I even allowed to say that in the podcast? Okay,
We don't
yeah.
have
So
censorship.
okay, take it with a pinch of salt then. I personally believe that this craze about building their own models is very short sighted and sort of unnecessary. See, China has been excellent in making hardware for the past 50 or 70 years, or some countries. So DeepSeek had many hardware driven innovations. They multiplied matrices better at a hardware level, though the invention may have been made in a different country, but implementing it on the ground in the hardware, they are very good. US has been very good at coming up with this innovative, novel new ideas. Okay, and which is what led to OpenAI actually to start with, and it's coming up with quite a few good things. India, on the other hand, which I represent, we have been excellent at taking these and converting it into services. Okay. Our biggest strength is not inventing hardware, not inventing software. But when a company says, I want to implement that hardware and software in my country, in my company, we were able to provide a fantastic low cost solution to them. Why should I do anything else now? If I'm really good at it, I built a $500 billion economy on this, right? So why should I now go and build my own language model? There are good language models. I didn't build my own Oracle, I didn't build my own SAP, so why should I build my own LLM? The fear here is the assumption that LLM will replace human. And so for me, at least, if I have my own LLM, at some top level jobs I will also have. So this fear is because AI will replace humanity, so I should have my own AI with my own culture, my own this thing. They will have, but I don't think anything like that will happen. AI will become a powerful tool. Those who do the mathematics of AI realize that it's anything but brain. It's 10,000 matrices multiplying an input vector into the output vector. Yes, 10,000 matrices are impressive. Each matrix having 10,000 rows and 10,000 columns make each matrix having 100 million numbers, so trillion total numbers. So it's huge scale, but no human got knowledgeable by learning entire Wikipedia to learn to predict the next word, and after that looking at 10 or 100,000 questions and corresponding answers. We didn't learn it like that. We are a very different species. Our strengths are different, our weaknesses are different, so we'll have our job to do. AI is a very powerful tool to do certain jobs better, certain jobs they automate. If I get that understanding, then I have to realize what are my strengths and practice that. If my country has a innovation system that generates brilliant mathematicians, I should focus on building those models. If my country has a system that will generate 1 million engineers every year, I should offer it as a service. If I'm really good at hardware, I should build better GPUs, alternatives to that. Or I figure out, some other country may realize they're very good at producing energy, which will become very important for AI. So they should focus on that. They should make better batteries. So it should be based on what my country's strengths are, what kind of resources I have, both people and physical, and what aspect of this I should specialize in. Yes, it's a good technology like alternative energy. This is a very good technology. So you should probably get a piece of the pie. But what piece you have to get, I don't think governments are thinking deeply about it. Everyone is going for an LLM. I think that's sort of silly. But anyway, again, This particular answer, please, I request the viewers to take it with a pinch of salt, a lot of salt actually.
And to pick up on another thread from earlier, current AI applications are largely focused on augmenting human decision making rather than replacing it. Is there a fundamental limit to AI's ability to be the final decision maker in high stakes scenarios like medicine, law, and national security?
Yes, right. Because it's not just about, see, AI learns, at least current AI. We don't know what will come out after 5 years, 10 years, let's say. But what we are doing, LLMs today, at its core, what are they doing? They are taking entire Wikipedia. There is normally a 3-phase process in this LLM training. The first phase is you take a large data set from the internet and train the system. It's a collection of 10,000 matrices. You train the system. Given some part of this text, it predicts the next word. That's all it will do. Now, at the end, and this is what takes 3 months, 4 months, that $50 million training cost goes in, training the LLM to predict the next word as accurately as it can from all the internet. And then I make humans write some 100,000 questions and corresponding answers and tell the system to learn from this 100,000 question and answer. At the end, it's able to simulate what most of the people for a given type of question, how are they answering? It is answering like that. And last thing, I will constrain it a bit to not completely go in a creative way. So I have answer it so that you align it as closely to this particular user group. So for example, if I want to visualize a female software programmers, a American visualizes them differently, a Saudi Arabian visualize them differently because of cultural background, whatever, the clothing, everything changes. So when I'm building a system there, I actually make the system closer to a human expectation. So these are the 3 phases. But what is it doing? It is predicting the one word at a time and getting it closer to your expectation, right? That is not how humans think. Firstly, I don't think one word at a time. And I'm not really worried about getting it close to your alignment either. I worry a lot more about my cultural, my background. I may say something that may not be really relevant in your culture, but it's okay. That's how we work. So human interaction is out of the box, non-aligned, and can be quite silly at times, which can be a very powerful idea in a different context. AI is trained to be as close to the knowledge that it has studied as possible, right? So I think a combination is the best way to do it. So today's AI, as we are seeing it as LLMs, etc., our diffusion models are about reproducing something they learned, learning patterns from there, and applying them to a new scenario. Our thinking is not just always that. We don't reproduce our learning and do it. Sometimes without any learning, I get into an argument, right? I mean, as a human, we do that, and that has its own value. That has its own utility function, right? So, is there a limit to AI's ability to be like human-like? Yes, because there are times when humans have to completely trash what they learned and start from scratch. That's very difficult for an AI to do. That's extremely. You may think it's doing, but it's not doing it. Completely different topic. Also, it's using what it knows. So absolute out of the box kind of thinking, reasoning, and AI today, as it is very constrained to do teamwork, because this guy itself is a tremendously knowledgeable guy. Yes, the other guy can find a fault, and this guy in an agentic model, it works in a very structured way. Our teams don't, in humans, teamwork is a lot more fluid and dynamic, messy. And, being messy is not a bad thing all the time. Always. It has its own strengths. It is actually the best way to generate a new idea. So I was going through some videos some time back. He said, based on his experience, he realized that the best entrepreneurs don't have a business plan on day one, procrastinate a lot, and have always a backup. I mean, anything that you think is bad for entrepreneurship is what he thought is a good thing. So being messy is not always a bad thing, and that is the flavor that humans bring into the system, that the non-trained outputs and completely out of the box, out of data kind of predictions, discussions, which AI is not capable of. So I think that's a limitation there. Unless people come up with a completely new way of doing things, which people are saying, many people say LLMs as they are will stop existing in the next 2 to 3 years. I don't subscribe to that as much, but that's what they say. But maybe they'll come up with a different way of doing it. But another thing that we have to know is, sorry, I'm extending, but the one part we have to know is, even today, we don't know how brain works. So when we are saying we are building a brain-like system with the limits of the brain, what we are saying is on some data, how brain reacts, this guy is also giving a similar result. But we don't know how brain works. When I say we, I'm not talking about AI scientists, AI business guys. I'm talking about brain scientists. The guys who have been studying brain probably know 10% of brain or even less, right? So without even knowing how brain works, how can I say whether what I invented, hacked out, actually is brain? What I hacked is 10,000 matrices that can multiply really fast, and it's doing something impressive. Let's enjoy and build some systems based on that, but don't get any more philosophical than we need to.
It's asking about lessons learned from, like your, let's say, material science and engineering background. And you made a comment or comparison, to PhD students now where I think you said something along the lines of they've outsourced tables to calculators. So I wanted to pick up on that point. It's been in the back of my head. And, as AI is taking over complex cognitive tasks, are we enhancing human intelligence by offloading routine thinking, or are we eroding critical reasoning by fostering dependence? In other words, do you see AI pushing humanity towards deeper intellectual pursuits, or are we unknowingly outsourcing the very skills that define human intelligence?
This is a very good question for an academician, and which I am, at least I assume I am. But this is a bigger question to the academia in general. See, I personally think not learning tables by rote is a bad thing. It has its own advantages. Will I do 73 times 47 mentally? No, I will not. But that I know that 17.6 or 102 without thinking has its own advantages. But academia has to do a lot more research on it. So I personally think having humans continue to learn certain skills, certain tasks, like writing well, concisely, like doing the basic math, even though the chat GPT can do it, I think we should have some separate environments where I am devoid of all my tools and I actually think and learn. Of course, I think that is mandatory. So academia has to do research and identify the fundamental skills that humans have to build, despite the fact that AI, generative AI, is able to do it today. Once that part is done, I think once that skill is given, with the help of AI, humans can now solve much tougher problems. So, they will probably start thinking about creating antidotes for curing million viruses at one go, or making human lifespan 500 years, going to Mars in half a day, designing material systems for that. All that they will solve. So using AI to ask much tougher questions, solve much tougher problems, I think is an exciting era that is going to unfold. But we do have to care a lot about still having humans retain some fundamental skills. So educational system really need to think about it, research about it, and figure out what skills humans must learn, despite the fact that calculators, computers, and AI models can do them better and faster.
AI can uncover patterns at scales and complexities beyond human cognition, but can it ever engage in the true generative process of scientific theory formation? I mean, is there a limit to AI's ability to make conceptual leaps, moving from empirical correlation to first principles reasoning? Or could an advanced system one day propose entirely novel physics that defy human intuition yet prove experimentally valid?
Yesterday, Anand Jayaraman, I think he was there in one of the past podcasts, right? He shared a couple of papers with me where I think a Japanese university proposed an AI model that uncovered Newton's laws of motion from the data. So, again, are we there to do physics? No, but I personally think it won't be an automated system that will keep generating better AI. It will require a lot of human intervention. I believe that if we build the right AI systems, scientists can use them to make better inventions. So, with the power of this tool, see, just take a simple thing like periodic table. Based on periodic table, you can create 10 to the power of 65 new compounds. Just to get the scale right, 10 to the power of 20 is the number of hydrogen atoms in the universe. Right? 10 to the power of 65 is humongous. We probably touched upon less than 0.001% of all possibilities then. So, of course, using AI to simulate more, do more things, investigate more is always going to be great. So I said, right, going to Mars and coming back in a half a day requires materials that can take a fraction of the speed of light, right? 80%, 50% the speed of light, etc. So all those things, I think, will become feasible when you build these AI systems that can actually look at fundamental properties, and it will become possible. But will that be the will AI on its own figure out science and do it? I don't think we are there anytime soon. There are exciting developments, but still, I think AI can probably play a very powerful support role to a human, and it enables us to ask much tougher questions, solve much more challenging problems. I think we should leave it at that. At least with the given today's type of AI, I don't think they will automatically on their own. And I know even I don't think that will happen.
No question. After decades at the forefront of AI, what's the single most critical challenge that, if left unsolved, could derail AI's potential to benefit humanity? And is there a flaw in how we're designing, governing, or even conceptualizing AI? And if so, then what must be done before it's too late?
I think people are starting to think, but I think we really need to seriously think about energy. Where do we get? I think the AI by itself is going to grow nicely, but today I think AI is consuming 1 or 2% of all the electricity in US, which is a lot of electricity, lot of water. For us to build systems that are relevant, useful, we need a lot more energy. We need a lot more alternative sources. I think people have to start thinking about it very seriously. Otherwise, after 5 years, nothing else, just the economic considerations will just put AI on a backseat, making AI become so expensive that using people will become better. So unless we figure out maybe we should move all the AI systems to moon and do all the computations there, I don't know what it is. It's not a field of my expertise anymore, but I think energy is the biggest problem that we need to solve. I'm not worried about. I think this answer surprised you. It is not mathematics. It's not responsibility. All that, I think we are good. Whatever pace we are growing. Hardware is growing, but I don't think energy we are growing anywhere close. That's why Microsoft, Google, Amazon are investing in nuclear energy, not building nuclear energy. So I think that's a huge problem. We need some solutions there.
But why don't you just use your AI and material science background to just get us a Dyson sphere going?
Yeah, well, I may not be able to do it now, but I'm sure material science departments that are working on energy are already starting to look at it. I think we are making batteries that can store a lot more efficiently, cables that can transit electricity a lot more efficiently. So whatever little I know in energy, producing is only a smaller problem. Just if we can retain whatever we are producing, um, we solve majority of the problem actually. So yeah, and there is some work that's happening in nuclear fusion. I'm sure there'll be quite a bit of exciting research that happens in the next 5 years in energy generation.
At the end of the day, responsible AI is about making sure our models behave better than us, right? And because if history's taught us anything, it's that humans are not always the gold standard of responsible decision making. I mean, we built nukes before nonstick frying pans, sent a car to space before fixing traffic on Earth, and made AI smart enough to dominate chess grandmasters before we figured out how to stop autocorrect turning AI ethics into AI exotics. I mean, we trust deep learning to detect cancer, but somehow CAPTCHAs still make us prove we're not robots by deciphering hieroglyphic street signs. And let's be honest, most people are still clicking accept cookies without reading a single word. At this rate, AI will be running the world before human intelligence can reliably get past the login screen. But all jokes aside, responsible AI isn't just about building smarter systems. It's about ensuring they operate within ethical, reliable, sustainable, and accountable frameworks. Because in the end, the real challenge is not whether AI can outthink us. It's whether we can outthink our own worst impulses while we design it. To those who found value in this conversation, we invite you to like, subscribe, and check out past episodes of the SoothSight podcast. If you're interested in exploring opportunities for AI collaboration with Soothsayer Analytics, please reach out directly. My contact details will be in the description. I'm your host, Christopher Dole, signing off. Dr. Murthy, you were wonderful as always. Thank you, my friend.
Thank you. Thank you, Chris. I also enjoyed quite a bit, and your questions were really great, made me think. Thank you very much for the opportunity.
Thanks, sir.